Okay, so let's go to the, let me open my Jamboard also. Okay, so yesterday we just have a very a short introduction on the vector, okay? So can any students let me know that you can see my screen?
Yes, Miss, can see.
Okay, thank you. Okay, so remember yesterday I mentioned that vector is represented by the straight line, and the length of the line is actually proportional to the magnitude of the quantity, and there's also the direction, okay, for the vector, okay, which is showing by the direction of the line, okay. So that means when come to vector, they consist of two important things, which is the magnitude and also the direction. So for example, velocity that we mentioned yesterday, okay? So velocity is a vector, okay? So there's an angle, for example, here 45 degree, and the magnitude is 20 meter per second, okay? So this is a magnitude, okay? And as I say yesterday, if we have a vector with this direction, say with the magnitude of 10, okay, then if we have something, this is a vector A, okay, so if we have another vector with the same direction but double of the length, then we understood that the magnitude will be double as well, which is 20. Okay, so for your information. And then when come to vector, right, so remember they also indicate the direction. So if let's say this is a direction of the vector, right, so this is a vector. Okay, let's say I'm using direction, this direction, okay, then this one will be the opposite direction, same length, okay, I put minus A. Okay, let's say the red one represents the vector with the direction showing by the arrow. Then with a minus sign on the vector is showing opposite direction. And the length of the vector, the magnitude still the same. So with the negative sign is indicate the opposite direction. Okay, just for your information. Okay, so before we move on, so these are the notation we use. Then next, we will continue on the addition of the vector. Okay, so what is means by addition of the vectors? When we add the two vectors together, then the adding of the two vectors together, we call it as resultant vectors. Okay, resultant vectors means you combine, you add the two vectors together. We say resultant vector. Okay, so if you have two vectors and you would like to find the resultant vectors, so how are we going to find? Okay, what is a resultant vectors? So there are two methods here. One is nose to tail method, and the other one is parallelogram method. So if you have learned vector before, I believe you have learned about this as well. Okay, so now what is means by the nose to tail method? Okay, so for example, you have you are given two vectors here. So you have vectors of v1 with this direction. Then you have vectors for trying to get another color. Okay, we have another vector with this direction. Okay, so how we actually find the resultant vector? So let's say we go through nose to tail method. Okay, so nose to tail method means first we are going to draw the first vector. So this one is a V1. Okay, then from the first vector that we draw, right, from the nose, okay, from the nose, I'm going to continue the second vector, which is the V2 I'm showing just now. Okay, so can you see from the nose, I continue to draw another vector with the direction, right, with the direction that are showing. Okay, then can you see this is called nose to tail? Okay, nose to tail. And then how about your resultant vector? So the resultant vector is this one, the one in yellow color. Okay, so this is a resultant vector. Okay, so you can see you have V1, you have V2. So here we draw for V1 with the same direction, with the same length. Then we draw V2 again with the same length, with the same direction. Then the vector that we get here, the yellow color, okay, with this direction, this one is actually the resultant vector, the adding of the two vectors. Okay, the adding of the two vectors, okay, for your information. Okay, for your information. Okay, so this is nose to tail method. Okay, so the resultant vector with the length is showing in yellow color, the one that I highlighted in yellow, and this is the direction. Okay, so because for any vector, you need to know what is the length, okay, then the direction as well. Okay, so this is the first method, okay, and the second method, we call it as a parallelogram, okay, parallelogram. So now, okay, can you see this is actually come from the same vectors that we have just now, right? Okay, so we have V1 and V2, okay, so for the V1, this is a blue color, right? Okay, then we will draw a parallel line with V1, okay, opposite of the V1, we draw a parallel line, okay, then for V2, this is V2, right? Then we draw another parallel line with V2. Okay, so the whole thing is a parallelogram. Okay, because we have the sides are parallel. Okay, the sides are parallel with each other. Okay, then so where is a resultant vector? Then the resultant vector. Okay, so can you see both of the vectors are actually with the tails here, with the tails here, right? Okay, so from the tail of the both vector, okay, so when we draw for, when we're using parallelogram, right, the tails and the tails of the two vectors must be touched together, like what you can see here, V1 and V2, the tails are touched together, okay? Then, after you draw the parallel line, the line parallel to V2 and the line parallel with V1, then the parallel line is intersect here. Okay, the parallel line is intersect here. So now you joining the tail to the intersections point here, of the intersection point of the parallel lines. Okay, then the line that I draw, yellow color, this is the resultant vector. Okay, so this one is a resultant vector. Okay, so they are actually the same. Okay, you're supposed to get the same answer. Okay, either nose to tail method or parallelogram method. So please take note. Okay, and we can say it as a vector addition or resultant vector. Okay, so is that clear for the methods that I'm just showing? Is that clear? Because I think this one you should have learned before. If you have learned about vector, I believe you must learn about the resultant vector with the parallelogram method and nose to tail method. So maybe you don't call it as nose to tail method. I also can't remember what is another name. But I think parallelogram method is we always using this name, okay? Because after we draw the parallel line, we actually form a parallelogram, okay? So is that clear so far? How we get the resultant vector?
Yes, Miss.
Yes, okay. Okay, so resolution of the vectors. Okay, resolution of the vectors. So a vector can be resolved into two component parts such that the vector addition of the component part is equal to the original part. Okay, so a vector can resolve into two component parts. So the two component parts, right, when you combine it back, you will get back to the original vector. Okay, so normally the two components part that we resolve is referring to the horizontal and also the vertical component. Okay, so let's look at here, horizontal component and also vertical component. Okay, this is very important. Okay, so later part, I think we have about half of these topics is about the horizontal and vertical component. So you need to understand very well. Okay, so how you get to this horizontal component and vertical component. So as I say, half of the content for this topic is about horizontal and vertical component. Okay, so later, I think for another 1 hour, we will just go through on horizontal and vertical component. Okay, now let's say we have a vector f in this figure. So this is a vector f, and with the angle, okay, towards the horizontal. Okay, so this is the angle. Okay, so now can you see, if let's say this is a vector of the f with the angle of the theta towards the horizontal, then the horizontal component of the f will be f cos theta. Okay, will be f cos theta. And the vertical component will be f sine theta. Okay, so f cos theta, f sine theta. So y is cos, y is not tangent. Okay, y is not sine, y. Okay, so now can you see? Okay, so this part is a horizontal part. So let's say I'm using an x to represent it. So this is a vertical axis, so I'm using y to represent it. Okay, so now if I draw a triangle, okay, so you can see this is f, right? Then the theta. If I draw a triangle like this, so that means now I'm drawing a triangle. Okay, then if I draw a triangle like this, the vertical say is a y, the horizontal say is a x. Okay, so now, can you tell me what is the cos theta? Anyone? What is a cos theta when you look at this triangle, right angle triangle?
X over F.
Okay, x over f. Okay, correct. X over f. So if let's say this is a x over f, then what is the x? X will be equals to f cos theta. And what I'm getting here, I'm getting x, right? X, which is referring to the horizontal component. Okay, horizontal component. So which is x equals to f cos theta. Okay, x equals to f cos theta. Okay, so the same concept. Okay, so get the sine. What is the sine theta?
Y over F.
Okay, y over f, correct. So y over f, and if I rearrange it, y is equal to f sine theta. So f sine theta is a y, right? Y, which is the vertical component. Okay, vertical component. So now, can you see how I get the f sine theta, which is this one? Okay, so, okay, when come to the following slides, okay, so if we can able to identify the theta, okay, the angle of the vector towards horizontal, okay, so can you see the theta here is towards a horizontal line? Okay, towards a measure on the horizontal line. Okay, so if your theta is on the horizontal line, then if you want to get the horizontal component, it's always f cos theta, then the vertical component always f sine theta. Okay, so take note on this. Okay, then let's move on to next one. Okay, so now, okay, so let's look at another examples here. Okay, so for this example, we have the F maybe can refer to the two forces lah. Okay, so that means two vectors here. Okay, now let's say F1, F2 is another two forces, is two vectors here. Okay, then for the F1, F2, okay, so when we refer to F1, okay, say this is our F1. This is F1. So for F1, what is the angle? It's a theta 1. Okay, F1 is a theta 1. So now, what is the horizontal component for F1? The horizontal component for F1 will be F1 cos theta 1. Okay, F1 cos theta 1. Then what is the vertical component for F1? That means it's a F1 sine theta 1. Okay, this one may not see it clear. Okay, so this one is actually F1 sine theta 1. Okay, okay, now let's move on to the second force, F2. So this is another vector. So this is the line, and this is the angle towards the horizontal, right? Okay, so now what is a horizontal component for F2? That means F2 cos theta 2. So what is a vertical component for F2? Will be F2 sine theta 2. Okay, so can you see how they resolve it into two components? Okay, so now, okay, next part. Okay, come to next part, okay. Okay, what is the horizontal component? Normally we're using H because we're taking the initial letter for horizontal. Okay, so what is a horizontal component here? When you look at what we have just now, since we have two forces F1 and F2, there are horizontal component for F1, there also have a horizontal component for F2. So the horizontal component will be the addition of the two horizontal component from F1 and F2. So for F1 would be F1 cos theta 1 plus F2 cos theta 2. Okay, so this is a horizontal component. Okay, then for the vertical component, okay, so remember just now we have a vertical component from F1 and F2. So the vertical component, okay, we normally using V to represent it. So taking the initial letter for vertical, so will be the vertical component from F1 and the vertical component for F2, addition of the two components here. So this is the vertical and horizontal component. Okay, so okay, by referring to this, figure. Okay. Okay, for your information, okay, let me explain further. Okay, if you have this as a vector of F2, okay, then your vertical component and horizontal component, this one will be the horizontal component, be pointing to the right. Okay, so the vertical will be here, point to the top. Okay, so just now for F2, so this one is a different angle. Okay, then this is the horizontal component, this is the vertical component. You see the direction. Okay, but say, okay, let's say if I have, okay, the vector that means go to this direction. Let's say we have another force, then what is the vertical component? The vertical component will be here, pointing up. And what is the horizontal component? It will be pointing to the left. Okay, so please take note, the V and the H. Okay, so how about other direction? Okay, so let's say I have this direction. How about this direction? Okay, so this is, okay, maybe I'm showing you this one. Okay, so if we have F4, okay, then what is the direction of the horizontal component? Will be towards the left. The vertical means towards the bottom, pointing down, the vertical component. Okay, if I have another force, let's say F5, which is pointing to this direction, then your horizontal component will be with the direction of to the right, and the vertical component will be with the direction to the bottom. Okay, so this is the direction of the vertical and horizontal component. Okay, so please take note about that. Okay, please take note about that. Okay, and for your information, okay, so normally, okay, if we refer to horizontal component, if I refer to horizontal, so horizontal can be going to the right or going to the left. Okay, so we always, for the one pointing to the right, always refer to the positive direction. And the one pointing to the left, since it's the opposite direction, to indicate the opposite direction, then with a negative sign. Okay, then come to vertical component, right? Okay, so it's either point up or point it down. So we normally use it, the one pointing to the point up, okay, is referring to the positive direction. And the one pointing to down is the opposite direction. We normally is referring to negative sign. So please take note about this. Okay, it's because later we will deal with, sometimes you'll see, how come there's a positive? How come there's a negative value? Okay, then you have to understand that is indicate the sign. Indicate the direction. Okay. Okay, so now you may not really fully understand on this. So let's see how we actually applied it into some of the problems. Okay, so now let's look at this example. Samuel asking, so it's just like graph essays. True also, they looks corresponding to our coordinate system. Okay, so later when you go through the rest of the part, you can see it just looks like that. Okay, I would say corresponding to that lah. Okay, similar to that. Okay, okay. So next one is a static equilibrium. But as I say, when come to vector, the negative sign indicate the opposite direction. Okay, So of course, just now I'm showing you I'm referring to vertical and horizontal component, because when we say horizontal means either right or either left. If the right is positive, then left will be negative. Then vertical is either going up or going down. So if let's say up is a positive, then down the opposite direction will be negative sign. Okay. Okay, next one. Let's see some of the problems that is in static equilibrium. So what is means by static equilibrium? So that means things in the static equilibrium means they are in the rest. Nothing is moving. It's stationary. Okay, so we say static equilibrium. Okay, static equilibrium. Okay, when come to static equilibrium, right, the total of the horizontal component will be 0, and the total of the vertical component will be 0 as well, because nothing is moving, everything is stationary, okay, and is in rest. So at rest, so that's why it is equals to 0. Okay, so that's the idea. So now, let's say the examples that we involve here is regarding how to determine the tension in two ropes. And let's say we take the G as 10 meter per second square. So this one is referring to the gravity. So gravity is 9 point something, but we just round it up, we just take 10. Okay. So how to calculate the tension in two ropes? So the tension is happen here. Can you see we have two ropes is hanging an object with 500 kg, right? So and you can see this is the angles of the two ropes. Okay, 20 degree measure towards the horizontal line, and 45 degree measure according to horizontal as well. Okay, so these are the two ropes. Okay, so now, okay, how we actually find the tension? Okay, find the tensions of the two ropes here. Okay, so now you look at this diagram again. Okay, so let's try to understand the angles here, right? Okay, so since this is 20, then for this particular rod, there are two, right? Okay, let's say for this one, right? Okay, with the tension of T1. Let's say I'm using T1 to represent it. And then for another ropes here, so let's say with T2, the tension of T2, right? Okay, so now how about the angle? So since here is 20, right? That means here will be 20 degree as well. So if here is 45, that means here will be 45 degree as well. Okay, so this is the angle. Then next, okay, so now when you look at here, okay, we start with the horizontal first. The horizontal component. Okay, for the first one, we're referring to horizontal component. Okay, can you see what is the horizontal component for T1? T1 is towards this direction, so the horizontal component will be point to the left. Okay, then for T2, right, the horizontal component will point to the right. So can you see one is towards the left, one is towards the right? Okay, so if let's say this is in static equilibrium, okay, that means they are not moving, then the horizontal component for T1 and horizontal component for T2 must be equals. Okay, so the horizontal component for T1 will be T1 cos theta. Okay, then for T2, the horizontal component will be T2 cos 20. And they must be equals. These are the only two components that we have so far. Okay, this is the only two components that we have so far. So which is T1 cos 45 and T2 cos 20. So they are equals. Okay, and remember just now I say the about this one, the horizontal is actually total horizontal is equals to 0. So we are applying the same concepts here as well. Okay, so that means when you look at the horizontal component, okay, so we have T2 cos 20. This one pointing to the right. Then we have another one pointing to the left, so which is a plus of the negative of T1 cos 45. Okay, so why is a negative? Because it is in the opposite direction. So to indicate the horizontal component with the opposite direction, so I put a minus. So that means this one will be equals to 0. T2 cos 20 plus negative T1 cos 45 is equals to 0. Which is referring to the total fx equals to 0. Okay, so if you rewrite this, right, you will get this as well. That means T1 cos 45 equals to T2 cos 20. So the concept is the same. Okay, the concept is the same. But in order to solve it easily, so we always put it as the total at the left equals to the total of the right. Okay? Okay, now, so after we get T1 cos 45 equals to T2 cos 20, so from here, I'm trying to get T1. Okay, by rearrange the equation, so I have a T1 equals to T2 cos 20 divided by cos 45. Okay, then taking cos 20 divided by cos 45. Okay, let's try to calculate cos 20 divided by cos 45 degree. So I get 1.3289 T2 because I still have a T2 here. Okay, so T1 equals to 1.3289 T2. Okay, done for the horizontal component. Then next one, come to next one. Next one is a vertical component here. Okay, so here is a vertical component. So when come to vertical component, okay, so let's look at T1. So what is a vertical component for T1? Is here. Okay, point out. Okay, then if we look at the T2, where's a vertical component for T2? Also pointing up. Okay, so that means going up, we have two vertical component, which is T1. The one come from T1 will be T1 sine 45. The one come from T2 will be T2 sine 20. Okay, then can you see another one which is pointing down, which is come from the object? Okay, the object of 500 kg. Okay, so but this one haven't include the gravity. So to include the gravity, so the 500 we multiply by 10. So remember just now we assume gravity is a 10. So 500 times 10, so I get 5,000. So can you see the total to the top, which is T1 sine 45 and T2 sine 20. Then the one going downward, which is the object, 500 times 10, which is 5,000. Okay, 5,000 Newton. Okay, so this one, right? Okay, is applying the concept of Fy equals to 0. Okay, so remember earlier I say total horizontal component equals to 0, vertical component equals to 0. So we are applying this concept as well. Okay, so by applying this concept, okay, so the one pointing up, which is T1 sine 45 plus T2 sine 20. Okay, then the one with the opposite direction is 5,000, right? Okay, so indicate with the opposite direction, I put a minus. Then it will always equals to 0. Okay, so this is total Fy equals to 0. Okay, now if I rearrange this, so I'm going to have T1 sine 45 plus T2 sine 20 equals to 5,000. Okay, 5,000, which is same as this one. Okay, total towards up is equals to total towards the bottom. Okay. Okay, so Saad, can you see T1 sine 45, T2 sine 20 are pointing up? Both are pointing up. Okay, so say we using those pointing up is a positive sign. Then the one going down, because you hang the object what? Okay, so the weight is for these objects, of course, it will be towards down, right? So the objects and the vertical component of T1 sine 45, T2 sine 20 are the opposite direction. Okay. Okay, so now we get number 2, the vertical. Okay, so okay, then after that, okay, we already got, most important is you understand how to get the horizontal and the vertical. So once you know how to get the horizontal and vertical, then you can proceed to solve for T1 and T2. Okay, remember just now from the first one, horizontal component, I managed to get T1 equals to 1.3289 T2. So for the T1 that we obtain here, I'm going to substitute this T1 with 1.3289 T2. So which is I'm substitute with 1.3289 T2. Okay, then what I'm going to do with this one, okay, so I will take for sine 45 times 1.3289. So when 1.3289 multiplied with sine 45, I get 0.9397. Okay, 0.9397. Okay, so sine 45 times 1.3289, so is 0.9397. Okay, then for sine 20, when I calculate, I get 0.3420. Okay, so take the sum. Okay, for these two numbers, so I get 1.2817. Don't forget this is a T2. Okay, T2. Okay, so 1.2817 T2 at the left is equals to the right, which is 5,000. So from here, I can find T2, which is 5,000 divided by 1.2817. Okay, so I get 3901. Okay, once I get T2, right, 3901, then I can substitute into T1. Okay, I can substitute into T1. Can you see this one? You can substitute here the values for T2. Okay, so that means T1 equals to 1.3289. The T2 is a 3901. Okay, so which is 5184 Newton. Okay, 5184 Newton for T1. Okay, so this is the answer. Okay, is that okay so far? So you have to be careful. If let's say this one given as a 500 kg, you need to include the gravity. So become 5,000 Newton here. Okay, the measure of the force. All right. Okay, so if you can understand the problem earlier, so now I want you to try out this question.
Excuse me, miss.
Yes.
Can you go back, please? The previous one.
The previous one.
Yeah. So miss, like the 0.9397, from where did we get it?
Okay. Can you see I need to simplify this one?
Yes.
Right? So I'm taking sine 45 multiply 1.3289 to get this answer.
Oh, okay, miss.
Okay. Okay. So any other question? See, one question I need to draw a lot. Okay. So now. Okay. So I want you to try on the second one, second problem. Let me put it into the board. Everybody, let's try it now. Okay, so for problem 2, right, a load of 80 Newton is suspended by 2 wires as shown in figure 1. Determine the tension in wire 1, T1, and tension in wire 2, T2. Okay, it's already labeled which one T1 and T2, so you just follow it, okay? Then please take note, the objects here, they already give you the load of 80 Newton. So that means this 80 Newton already included the gravity. So you don't need to multiply by 10 anymore. Okay, so you don't need to multiply by 10 anymore. So that means this one is 80 Newton. Okay, please take note. You don't need to include the gravity. It's already included the gravity. Okay, okay, so now T1 and T2, and please start. Okay, so what you need to do is, say you find the horizontal first, and after you find the horizontal, then you find the vertical component. Okay, so for horizontal, we will always write the left equals to the right. So for vertical, we will always write the top equals to the bottom. Okay, so let's try this out. Okay, then later I will show you the solution. So, but you tried it out yourself first. Okay, and when come to the angle, right? So since we have 23 here, so that means the angle here will be 23 as well. Okay, so for the 45 here is 45, right? So the angle here will be 45. Okay, so let's start to work it out for this, the answer for T1 and T2 for this question. So I give you 5 minutes. So that after we discuss, then you can go for break. Okay, done. So what is the answers you get? Anyone? Okay, so we have 3 sets of the answers here. Answer for Samuel is different with another 2 students. Okay, so let us have a look. Okay, how we actually get the answer. Okay, so for the horizontal, right? Okay, so for T1, this is a horizontal component. T2 is towards the right hand side. So for T1, it will be T1 cos 45. For horizontal, we always using cos, right? Then it is equals to T2 cos 23. Okay, T2 cos 23 and T1 cos 45. Okay, then from here, I can get T1 as T2 cos 23 divided by cos 45. And then we calculate cos 23 divided by cos 45. And we get 1.3018. So let's say I follow 4 decimal places given in the slide. 1.3018. Okay, T2. Okay, so this is what I get for the horizontal part. Okay, so next part. Okay, so next part is the vertical. Okay, so vertical for T1 and T2 both point towards up. Okay, pointing up. Okay, so that means T1 sine 45, okay, plus T2 sine 23. Okay, then equals to the one going down, right? So which is the load? 80 Newton. Okay, 80 Newton. Okay, so now we already got the second equation. Just now this one is the 1 and this is 2. Okay, so for the first one, right? Yeah, just now we have, let's substitute this one into here. Okay, so that means we have 1.3018 T2. 1.3018 T2. Okay, substitute the T1, then followed by sine 45, then plus T2 sine 23 equals to 80. Okay, now let's calculate 1.3018 multiply sine 45. So I get 0.9205 T2. Okay. (0.9205 T2 plus sine 23, which is 0.3907 T2 equals to 80. Okay, now take the sum. Okay, 0.3907 plus 0.9205. So which is 1.3112 T2 equals to 80. So find T2. T2 which is 80 over 1.3112. So I get 61.01. Okay, 61.01 Newton. Okay. Okay, then next Okay, I would like to get T1. So when I get T1, I refer back to this one, right? Okay, so for T1 is equals to 1.3018. Substitute with T2, 61.01. So I get 79.42. Okay, 79.42. Okay, so yeah. Okay, so is that clear now with the second problem?
Hi, Miss.
Yes.
Can my answer can I put in 4 decimal places? Or you have to put 2?
For the Newton, normally we may not need so many decimal places, but even you put in 4 or 2 doesn't matter lah to me. Okay.
Okay, Miss.
Okay. Okay, what do you mean by T is opposite with mine? Okay.
Miss, for us T2, then T1 switch with yours. I think that's what you mean. It's like my T2 is.
But can you see, because of the questions giving the T1 and T2 already, so I follow exactly the diagram. You're supposed to follow the diagram. Correct or not? Okay, guys, if let's say this is happen in your assessment, if the diagram is already given, and they already indicate this is T1, then this is T2. So, of course, you have to follow, right? Okay, you have to follow exactly with the diagram given. So else is wrong already, right? Okay, correct or not? Unless the questions never give you the T1 and T2, then you using your own T1 and T2, then of course, it should base on your answers, okay? It should base on your workings, then to give you the mark, okay? So please take note, I follow exactly the diagram given, supposed to be, okay? Okay, so yeah, if let's say things are clear, okay, just need to take note, okay, which one is T1, T2. If the diagram is already given, you must follow exactly. Then I think should be okay, right? Okay, so now this one is just involve two forces, okay? So later we will move on to more, okay, forces. Okay, so I give you a 10 minutes break. Then after that, we'll continue. Okay, so we continue after 10 minutes. Hi, let's continue. Take the attendance first. Today is L4. Okay, take your attendance. Okay, so all present, very good. So far our attendance are good. Okay, so I'm very satisfied. Okay, so let's move on to the slide. Okay, so just now we are with the problems which is in static equilibrium. So then this one is non-equilibrium system. Okay, then let's see how we actually find the resultant forces. Okay, resultant vector. And again, we are going to use the trigonometry that you learned in the first topic. Okay, and if you understand very well how we do it for the complex numbers, when you find the arctangent, when we deal with the complex numbers, I think you can understand this one, not a problem. So that's why, can you see earlier one, I keep on asking you which quadrant, how to find the angle, don't put the sign and so on. So now you will see you are going to need it again for the calculation. Okay, so for non-equilibrium system, okay, having obtained H and V, H and V are referring to the horizontal and vertical component. So the magnitude of the resultant vector is actually given by square root of H squared plus V squared. Okay, so when come to the magnitude of the resultant vector, we're using capital R as a notation. So which is with the square root of H squared plus V squared. So H, which is referring to the total horizontal component, and V is a vertical component. Okay, and then the angle to the horizontal is given by the following. Okay, so okay, it's I think something missing here. So it is given by vertical arctangent of vertical divided by horizontal component. Okay, vertical component divided by horizontal component. So remember when we learn complex numbers, how you calculate the argument. We always take arctangent of y over x, right? So can you see the concept here? They are corresponding. So we are taking the vertical divided by the horizontal. And then, okay, so what is the angle here? The theta is actually depend on which quadrant the angle falls. Okay, so that means I will suggest you not to put the sign as usual. Then you just, after you calculate the basic angle first, then you calculate accordingly, okay, follow which quadrant of the vectors that you have. Okay, so please take note. Okay, now let's look at this example. Okay, determine the magnitude and direction of the resultant force. So can you see for this example, we have two forces here. One is 4 Newton, okay, with the direction of 45 degree to the horizontal. The other one is 7 Newton is to the horizontal, with the direction of to the right-hand side, the horizontal. Okay, so now if I want to find the resultant force, then I need to find the horizontal component, the total horizontal component. Okay, so let's start with the H, right? Okay, so can you see for 7 Newton is exactly pointing to the right. So 7 Newton itself is already the horizontal. So that means the angle to the horizontal is 0. So which is 7 cos 0. Or you can just write as 7 because cos 0 is actually giving you 1. Okay? Okay, then for 4 Newton, okay, the horizontal component will be 4 cos 45. Okay, so we add it up, the value, and we get 9.828. So this is the total horizontal from the two forces. Okay, then the vertical component of the force, okay, so which is V, okay? Then let's calculate for the 7 Newton. So for 7 Newton, the vertical will be 7 sine 0. Okay, so can you see the angle always the same? It's just changing the cos to sine. So for horizontal, we always using cos. For vertical, we always using sine. That is also provided your angle is to the horizontal. Okay, so in order not to confuse you, okay, confuse yourself, so we always read the angle to the horizontal. Okay, we always read the angle to the horizontal. So this is what I mentioned. Why I say to the horizontal means either measure, to the horizontal here or horizontal here, right? Okay, so this one is measured to the horizontal. Then when you calculate for horizontal component, you will always put cos. Then when you calculate for vertical, you will always put sine. Okay, if your theta is to the horizontal, so you won't get confused. Okay, so next one, for the 4 Newton will be 4 sine 45. It's just change the cos to sine. Okay, then you calculate. So for 4 sine 45 is 2.828. So you get the vertical component of the force is 2.828. Okay, so you have horizontal, you have vertical. Okay, so now the magnitude of the resultant of vector. Okay, what is a magnitude? Okay, what is a magnitude? So the magnitude is actually calculated by, okay, we can using R equals to square root of H square plus V square. Okay, the magnitude of the resultant of the vector. So when we say resultant of the vector means the addition of the vectors. So the magnitude will be square root of H square plus V square. So for the one that we get just now, we just square it and taking the sum, then get the square root. So we get 10.23 Newton. Okay, 10.23 Newton. Okay, then how about the direction? Okay, the direction of the resultant vector, because the vector must have the magnitude and the direction. So the direction will always taking vertical divided by horizontal. So since your vertical is 2.828, your horizontal is 9.828. So arctangent of 2.828 divided by 9.828, you get 16 degree. Okay, you get 16 degree. So now, is the angle is 16 degree because we are calculating basic angle first. Okay, we always calculating the basic angle first. Then how we know whether which quadrant is a resultant vector? Okay, then you look at your horizontal and vertical. So this is a horizontal, this is vertical. So vertical and horizontal are both positive. Okay, are both positive. So that means if your horizontal is positive means to this direction. So if your vertical is positive, means towards this direction. So where is the resultant? So the resultant vector will be here. The resultant vector will be here. That means in the first quadrant. If let's say in the first quadrant and the angle you found is 16 degree, so that is the angle. Okay, so the resultant of the two forces is a single vector of 10.23 Newton at 16 degree to the 7 Newton vector. So that means 16 degree to the horizontal lah. Okay, so they're just using 7 Newton vector as a to show the direction. So that means 16 degree to the horizontal. Okay, so this is the how we calculate the resultant magnitude of the resultant forces, resultant vector, and also the direction. Okay. Okay, so is that clear so far? Can you see what you're doing here is actually corresponding to what you did for the complex number. And then, of course, you need the knowledge from the trigonometry. Okay, is that fine so far? Can understand?
Yes, miss.
Okay, then I will move on to, okay, so I think after the slide I'm showing here, okay, this one will be the last lecture slide I go through with you. Then because the next part is another part of the topic. So after this, this slide, then we will, if we have time, we will continue the tutorial, okay? So we'll continue the tutorial questions that is related to what we have gone through so far, okay? Before we go to another part, which is something a bit very different from this one. Okay, so this is an example of non-equilibrium system. So you have 4 concurrent coplanar forces acting about point O as shown. Okay, so find the magnitude and angle of the resultant forces. Okay, this time you have F1, F2, F3, and F4. You have 4 forces here. Okay, you have 4 forces here. And please take note, this one is 25 degree to the horizontal. This one is 40 degree. And this one is 15 degree. And this one is 60 degree. Okay, so there's a tables given here to guide you for the calculation here. Okay, so how we do this calculation, then let me show you in the whiteboard, okay, in the Jamboard. Okay, so come to this question, okay? So you involve 4 forces here, okay? Then say you want to find the magnitude and angle of the resultant forces. So that means resultant forces means you combine, when you add all the 4 forces, what is the resultant forces you get here? Okay, so find the magnitude and also the angle. Okay, let's say we start with horizontal. Okay, so say I construct this table. Okay, so let's say we have forces in Newton. So we have the F1, which is okay, F1, which is 40. Okay, F1, 40. Then F2 is actually F1 40. So F2 is actually 50. And F3 is actually 60. And F4 is actually 80. Okay. Okay, so now let's start with the horizontal component. Okay, so for the horizontal component, okay, and the last is a total. Okay, so now start with the first one, F140. So F1 is in the first quadrant, right? It's in the first quadrant. So I will just, first quadrant is easy. I just calculate as the horizontal will be 40 cos 25. Okay, 40 cos 25 degree. Okay, okay, then later we'll calculate the value. Okay, next one. Okay, for next one, right? Okay, F2 is 50 Newton. Okay, so the horizontal will be here. Okay, so can you see it's the opposite direction? So this one towards the left. So for those towards the left, okay, you will put it as negative 50 cos 40 degree. Okay, negative 50 cos 40 degree. Okay, or there's another way. Okay, so if you think to include the negative sign is actually confusing sometimes, then you can have another alternate way to calculate it. So instead of put negative 50 cos 40, okay, you can just put it as, can you see the angle from here to here? What is the angle? 180 minus 40, 140. 140. So you just calculate as, you don't need to put any sign. You just put 50 cos 140 degree. 50 cos 140 degree. Okay. So when you put the angle that you measure from the positive x-axis, okay, so another way is the angles that you put, right, is all measured from the horizontal, positive horizontal x-axis, okay? Then you don't need to put the sign because cos 140, right, okay? So 140 is actually in the second quadrant. So second quadrant is always negative for cos, okay? So you don't need to think about the sign. You just put cos 140. When you calculate in the calculator, it will give you the sign. So you understand what I'm trying to say. If for the first one, you're using basic angle. So when you use the basic angle to calculate, then you need to indicate the sign. Okay. So another way is you don't put the basic angle. Okay. You just use the angle measure from the positive x-axis, 140. Then when you calculate cos 140, it will give you the sign. Okay, if let's say it's either positive or negative. Okay, when you calculate through the calculator, it will give you the sign. Understand, huh? Okay, so next one, let me proceed. Okay, so when come to F3, right? F3 is a 60 Newton. Okay, 60 Newton. So can you see, if I want to use the basic angle, I cannot take 15. I have to take this angle. So 90 degree minus 15 is actually 75. And can you see 75 is pointing, the horizontal component for F3 is pointing to the left. So will be negative 60 cos 75. Okay, negative 60 cos 75. Okay, or as I say, if you don't want to feel headache with putting the sign, thinking on the sign, then you just use the angle that is measured from the positive x-axis. So from the positive x-axis come to here will be, what is the angle? 180 plus 180 plus 75, 255. So you just calculate as 60 cos 255 without putting any sign. Okay, so let the cos 255 to give you the sign. Okay, so next one, F4. Okay, come to F4, right? Okay, so we need, if you use the basic angle, then you need to get the basic angle here. Basic angle always calculate on the horizontal. So here will be 30 degree. Okay, 30 degree. And can you see the horizontal component for F4 should be pointing to the right, so it's positive. So that means this one will be 80 Newton cos 30 degree. Okay, 80 cos 30. Okay, or if you don't want to use the basic angle, then you can calculate as, okay, again, so you measure your angle from here to here, then will be 330. 330. So that means the force is 80 Newton cos 330. Okay, then let's calculate the value. Okay, let's calculate the value. Okay, so for the first one, 40 cos 25. $36.25. Okay, 36.25 Newton. Okay, then next, okay, second one, negative 50 cos 40. You get negative 38.30. And when you calculate, can you see you get a negative value? And when you calculate 50 times cos 140, right? Can you see you getting the negative as well? Okay, because cos 140 in the second quadrant, for cos, right, it is negative. Okay. Okay, cos is negative for second quadrant. Okay, then you move on. So next one is negative 15.53. Okay, then of course, if you calculate 60 times cos 255, you get negative 15.53 as well. Okay, so definitely they must be the same answer. Okay, so for 80 cos 330, it will be 69.28. Definitely they must be the same. Okay, so okay, so can you see you can use either way? And if you ask me, to me, right, I will say that using this will be easier. The second one, how do you think? Okay.
Excuse me, miss.
Yes.
Like, why for the F4, like, we didn't do like negative 80?
Okay, so can you see F4? F4 is here. So where is the horizontal? Horizontal component is here. Point to the right, so it's positive.
Oh, okay, miss. Like, when the horizontal is pointing to the right, it's positive, and when it's to the left is negative, yeah?
Yes, yes. Okay. So that is how you use the basic angle. Okay. So if you don't want to feel headache on finding which one is positive, negative, then you don't use basic angle, because sometimes, right, basic angle we also need to recalculate. So else you can just use the second method. Second method, we don't put the sign. we just use the angle measure from positive x-axis. Okay, to me, I will suggest use the second one, the one I'm showing in yellow color. Okay, get it? Right? Okay, so what you need to do for the next? So the next, you need to find the total horizontal component. Let's total up. And please take note, when you total up, you have to take note because sum is negative. So you need to subtract them. Okay, so when you total up, you get 51.7. Okay, 51.7. So that is the total for horizontal component. Okay, get it? Okay, so now, okay, you will proceed to calculate vertical component. So to calculate the vertical component, right, basically is the same. You just, of course, you can also choose basic angle, or you can also choose the angle measure from the positive x-axis. Okay, so you just need to change the cos to sine when you calculate for the vertical component. Okay, when you calculate for vertical component. Okay, so okay, then vertical component. Okay, so for the vertical component, the first one, instead of cos, I just change it to sine. For the second one, same things, 50 sine 140. Then 60 sine 255. Then 80 sine 330. Okay? But when you use the basic angle, right? When you use the basic angle, okay, if you're using the basic angle, the first one, okay. This one I'm using the angle measure from the one. So if you're using the basic angle, then I think, hold on, let me check. F1 is positive. F2 is also positive. Okay, you see. Okay, I think I show you both. Okay, so if you're using the basic angle, the first one is a 40 sine 25. Okay, so for second one, 50 sine 40. But what is the sine? What is the sine? Okay, when you look at F2, F2 is here. So the vertical component is to the top. So it's a positive. So here you put positive. Okay, so the sign will be changed if you using basic angle. So that's why it's more troublesome. Okay, then if you look at next one is 60 sine 75. Okay, but how about the sign? F3. Okay, so when you look at F3, F3 is here. So your vertical is towards down. So towards down, then you need to put negative. So if you're using basic angle, right, the sign may not follow the sign of the horizontal. Then you have to take note. Okay? Okay, so next one, for F4, can you see is here? The vertical is pointing down. So you need the negative also. So you have to be careful. Okay? Then if you're using the another way, okay, so you have no worry. If you're using the method which is measured from the positive x-axis, so first one you calculate as 40 sine 25. Then the second one you just calculate as 50 sine 140. You don't need to think about the sine. You just change the cos here to sine. So next one will be 60 sine 255. So next one will be 80 sine 330. Okay, so I will recommend you to using the second one. Okay, and you're supposed to get the same answer. Okay, so 40 times sine 25, you get 16.90. 50 times sine 140, so will be 32.14. Okay, so 60 times sine 255, it will be negative 57.96. Okay, then 80 times sine 330, it will be negative 40. Okay, so when you calculate using the basic angle, is also the same answer. This one is also 16.9. This one also 32.14. This one will be negative. And this one will be negative also. Okay, so then you need to calculate the total up. So be careful because you have negative value. So you have negative 48.92. Okay, negative 48.92. Okay, so this is the vertical component. Okay. So, as I say, I will strongly recommend you to using the angle measure from x-axis. Okay. Okay, now, so you already get the total horizontal, total vertical component. Okay, then the next is to get the magnitude. Okay, so that means this one is a V. Okay, so that means what you have here, this one is a H, this one is a V. Okay, so the next you need to calculate the magnitude of the resultant vector, resultant forces. So magnitude okay, is R equals to square root of H squared plus V squared. So the H is 51.7 plus V is actually negative 48.92. Okay, so take the sum, square and taking the sum. So 51.7 square plus 48.92 square. So 71.18. 71.18. Okay, so this is a magnitude. Okay, so resultant forces. Okay, then next one. So actually this one is also in Newton. Okay, then next one, the angle. Okay, the direction, the angle of the resultant forces. Okay. Angle of the resultant forces. Okay. So remember, arctangent of V over H. Okay. So here you have a negative, you have positive, but as I say, I don't include the sign. So I have vertical 48.92 and I have horizontal 51.7. 48.92 divided by 51.7, so arctangent. Okay, arctangent. Okay. Calculate the basic angle first, so you get 43.42 degree. Okay, 43.42 degree. Okay, this is a basic angle. So now, okay, can you tell me if the horizontal is negative, vertical is negative, horizontal is positive, which quadrant?
Fourth quadrant.
Fourth quadrant. Okay, so now let's check it out. Vertical is negative means going downward. Horizontal is positive means going to the right. Okay, that means the resultant forces is in the fourth quadrant. Okay, fourth quadrant. So for the fourth quadrant, how we calculate the angle? Okay, so from here to here, okay, the theta is 360 degree minus 43.42. Okay, 360 minus, because here is 43.42, the basic angle. So 360 minus 43.42. So 316.58. Okay, 316.58. Okay. Okay, so this is the angle, fourth quadrant. Okay, is that clear? I purposely slowed down, okay, to let you understand, okay, this one. So is that okay? How to find the angle?
Yeah, okay, miss.
Okay, so the rest of the students, is that clear? Okay, so that's how we calculate when we have a few forces. Okay, and for what we have gone through today, you can go through number 1 to number 7. Then again, for the next class, I think we will just spend the 2 hours time just for this question. Okay, deal with the calculation. Okay, clear? Okay, so practice question 1 to question 7. Okay, then next Monday, we will go through this question. Okay, next Monday we'll go through this question. Okay. Okay, so any other question? So this one also quite a lot of the calculation here. No, so far. Okay, so since no question, then we just have another 5 minutes. So I will dismiss the class. Okay, hope that is clear for you. Okay, so today, let me have a review on what we have learned. Okay, so we have touched a little bit on the resultant vector by using nose to tail and also parallelogram method. But we actually more emphasize on using on the resolution of the vectors. Okay, resolve the vectors into two components, horizontal and vertical. And please take note, if the theta is actually to the horizontal, we will always calculate the horizontal component by the cos, and then vertical by the sine theta. Okay, then we have gone through the problems regarding static equilibrium. Okay, so when we calculate, we always, for horizontal, right, we always using the one at the left of the horizontal equals to the one at the right of the horizontal component. Okay, then for vertical component, we always take the total to the top, okay, and equals to the one to the bottom. Okay, so that is for the vertical, and then we solve it for the T1 and T2 for this kind of problems. Okay, then next, and you have to take note, if you have an object, okay, giving you in kg, not yet include the gravity, then you have to include the gravity. But for this one, it's already give you the load of 80 newtons, so it's already including the gravity. So you don't need to include anymore, okay? Then for the next problem is for non-equilibrium system. So we can find the magnitude of the resultant vector by square root of h squared plus v squared. H is referring to horizontal component, v is a vertical component. Then for the angle, is arctangent of v over h, vertical divided by horizontal component. Okay, then this one is involve a few forces, and I already show you how we do the calculation just now. And as I say, I recommend you to use the angle measure from the positive x-axis, will be easier. Okay, then you can just calculate the magnitude as usual. Arctangent also, I already taught you many times. Okay, okay, so then that's all, okay, for today. Then I will see you next week. Okay, I think most probably next week we can get it done already. Okay, next week or the first class of the last week. Okay, I think we can finish. So the last class we will do the revision. Okay, okay, then that's all for today. Okay, bye students. See you next week. Bye bye.
Thank you,
Thank you,
miss. Bye
miss.
bye. Have a nice day.
Yeah, welcome. Bye.
Thank you, miss.
Yeah, welcome. Bye bye.